You should be live now. Yeah.
Great. Hi, everyone. My name is Ian Cordasco. Nikhil invited me to give you a presentation about how OpenStack is going to start using Betamax. So before I get started, you can find me on GitHub, GitLab, Twitter, and IRC with this handle, SigmaVirus24. There's a long story behind it. You don't want to know why I use that. In short, I am a Glance core reviewer, I'm a hacking core reviewer, I'm a Bandit core reviewer, and I maintain the requests library, Betamax. I authored the request toolbelt. I help maintain urlib3. I maintain Flake8, Pep8, PyFlakes, McCabe, and a few other things related and around Flake8. I founded the Python Code Quality Authority with some people from Pylint and other projects. I maintain Twine within the Python Packaging Authority, and I do a bunch of other things. And also I'm a Rackspace Private Cloud developer. Rackspace Private Cloud, for those who don't know, is just an open source product that deploys OpenStack in a highly available manner in your data center or in Rackspaces. And everything is open sourced under the OpenStack Ansible project and upstream OpenStack, as well as our customizations that live in a different GitHub repository. So the outline for today, I always like to make sure that everyone's on the same page when I'm talking about things. So I will briefly go over how things are tested in OpenStack, which includes test fixtures, because that's important for a later part of the talk. I'm going to go over requests a little bit, cover Keystone and Keystone Auth and how those fit into OpenStack real quick. And then I'll dive into what Betamax is, why you'd want to use it, how you would use it, and then finally how Betamax is going to be used in OpenStack. So let's get started with testing in OpenStack. Pretty much every project in OpenStack is tested to some degree. Every one of those projects uses test tools. It uses test repository to run the tests and keep a running count and statistics about the test runs that have happened, test failures. Whenever you run tests inside of OpenStack, if you rerun the tests later after you fix a test, it'll tell you the difference in the number of failed tests, right? So it might say, oh, there's 20 more failed tests, or there's 10 less failed tests. Pretty much every project uses fixtures, and pretty much every project uses the mock library. And test tools, test repository, fixtures, and mock are all maintained by a group called the Testing Cabal. One person in that Testing Cabal who's kind of the leader is Robert Collins, also known as Lifeless in OpenStack. You also use talks, but that's not so important to this talk. Pretty much every project uses XUnit style integration and unit tests. And what I mean by that is every test that's written is part of a class, a test class. If you're familiar with other testing libraries like Nose and PyTest, you can pretty much write functions as tests instead of using an entire class. But because of OpenStack's age and tradition and standardization, we all use test tools and the XUnit style testing classes. Some projects also distribute test fixtures, and I'll kind of go over what test fixtures are in a little bit, as well as give you an example of which projects do that. So test fixtures are just a reusable object that kind of contains their own logic for both setup and teardown. So as an example, this is directly from the test fixtures libraries README. You have some fixture that you want to create that you call it the naughty fixture. And that fixture needs to have an attribute called frog nozzle. And you want it to be 42 at the start. What you might do is you might use this fixture and something in your test, and what you're testing rather, might change the value of frog nozzle, and then you would make an assertion about the value of frog nozzle afterwards. But in between tests, you'd want it to be cleaned up by removing that attribute. That way, the next time you set up the naughty fixture, it ends up being 42 again. Now, this is a little bit of a overpowered example, right? Because each time you set up the fixture, you don't need to not have that attribute there. You can always just set it to 42 and override whatever the previous value is. But this example shows you how you would define what happens before you use a fixture and what happens after. And so instead of defining your own cleanup method like you might in an XUnit test class, you just tell the fixture that you want to add a cleanup using the add cleanup method. And then it can be a function, and you give it the parameters. And so this is just a very, very simple, not really useful example of how to create a fixture. There are far more complicated examples in OpenStack, but I couldn't find one that was simple enough that I could explain it in a few minutes in a slide. And just to give you an example of other kinds of fixtures, you have fixtures that can reuse other fixtures. And this is another example just from the fixtures README. So in this example, we're showing you that you can call useFixture, which is a method on every fixture. It's also a method on every test tools test case instance. And so you just pass it the naughty fixture instance. And because you're telling it that it's a fixture, it will know to call the setup and teardown methods and cleanup methods and everything else for you. You don't have to do any kind of extra logic around it. It's very nice. And finally, just because I want to show the very excellent flexibility within the fixtures library, there's a class called the function fixture. And what does it take? A setup function, or a function to call during setup, and a teardown function, or a function to call down during the cleanup. And so once you call the setup method on the function, you can assert that, for example, here we're using temp file to make a temporary directory, right? After we've called setup, we can assert that the result of that function call is actually a directory that is on the file system. And then once we clean up, we could also assert that it doesn't exist anymore. So the API is pretty simple. As we showed, you have the underscore setup method, which is preferred to overriding the setup method itself. You have add cleanup. Whoops, I thought I had a different slide there. You have the use fixture method. You have and a bunch more like reset, which is kind of useful in the middle of a test to reset a test fixture. And that's if you want to have multiple test cases in one method. So moving on, because this is just supposed to be kind of a rehash. That way, people who don't know what's going on have a rough idea of what's happening. Anyone who's forgotten also knows what's going on. We'll touch on requests. I hope most people know what requests is. It's one of the most popular libraries on the Python package index. But for those who don't, its tagline is HTTP for humans. And what that means is it's a library that handles the hypertext transfer protocol in a way that's very, very simple for other humans to use. It's easy to read. It's light on the eyes. And for those who don't know what HTTP does in OpenStack, OpenStack is just a set of APIs that interact with the consumers over HTTP. And some of the services interact with each other over HTTP. Pretty much everything in OpenStack is done over HTTP, except for when you send like a message to RabbitMQ. That's a different protocol entirely. There's a few examples of things that are not HTTP, but for the most part, everything is HTTP. So requests provide a number of benefits. Connection pooling is one. That's probably the biggest reason for using requests for anyone. And what that means is that it reuses sockets. This is important because on pretty much every system, creating a socket can be expensive. And so when you reuse those sockets at the same server, your client will actually be faster. Requests also has correct on by default certificate verification over TLS. If you're not familiar with what that is, think of your browser. And when you see that green lock icon in the upper left-hand corner when you visit a website, it's basically that, except we don't have a lock icon for you. Requests does data handling, so it can convert to and from some very popular formats. Specifically, what OpenStack cares most about is JSON. So there's a JSON parameter to most of the methods in requests that will take a Python object and convert it to a JSON representation. And every response object, as I'll show you, has a method called JSON on it that will take the response body and convert it back to a native Python object. So you don't have to use json.loads or json.dumps. Everything is kind of handled for you correctly by requests. As I said before, request does the right thing for about 98% of its users by default. For the last 2%, we provide them workarounds that are not hard to use, but they're not built into the native API. So if there's something that's a little tricky for you, you might have to do a little or a lot more work to get it to work with requests. But in the end, you can still reap all the other benefits of requests, just having to do some custom code by hand. And we refuse to help the other 2% because it's usually something that's very bizarre and very rare. So giving them the tools to solve it themselves is better, in our opinions, than trying to solve it for them. And finally, our documentation was recently updated to say that request was the only non-GMO HTTP library for Python that's safe for human consumption. I just threw that in as our joke to kind of hopefully alleviate some of the seriousness of the talk. So let's look at some code that uses requests. We create a session. The session object is what powers all the connection pooling. When we have that session object, we just make a GET request to a website. In this case, we use h2bevn.org. And then we pre-print the JSON response. There's other attributes on the response, but this is just a very simple, very quick example. There's other methods on the session object like post, put, patch, delete, options, head. And then if you have some other HTTP method that is not covered by one of those, you can just use session.request. So hopefully everyone's following along pretty well and has no questions about requests. So let's move on to Keystone and Keystone auth. Keystone itself is the identity service within OpenStack. Hopefully everyone's familiar with it. If you're not, and you're wondering why does Keystone matter, for most, anytime you use DevStack or pretty much any OpenStack-based cloud, when you use a client like, say, Nova Client or Magnum Client or Glance Client or anything else like that, what usually happens first is that that client talks to Keystone with your username and password and all the other information that you might have, and gets a token for you. What then happens is that the client sends that token to the service you're trying to talk to, whether that be Nova, Glance, Magnum, whatever. The service then has some middleware between it and you that talks to Keystone and says, is this a valid token? And if so, give me what permissions this user has. When that comes back, it's given to the service, and the service can determine whether or not you're authenticated and whether or not you're authorized to do whatever you're trying to do. And so Keystone is the identity service in OpenStack. Keystone Auth is a library that is developed by the Keystone team. Previously, any client that would talk to both Keystone and another service would use Keystone Client itself. This caused a lot of headaches and problems between dependencies and compatibility problems between different versions of the Keystone client. So what the Keystone team decided to do, along with the help of many other people from within the community that needed this library, was to define a much smaller API that just handles retrieving authentication and authorization tokens from Keystone and providing that to the library. It also handles plugin loading for different kinds of identity types. But it's basically the core functionality that any client library might need. And so what happens with Keystone Auth is that it's a very stable library. And so it's just something that's simple that is very focused on just the auth portion, whereas Keystone Client is focused on auth and talking to Keystone for using Keystone's API. So you're probably wondering, like, why would we need another library? Basically, it's just so that everyone has a much simpler interface to Keystone for retrieving authentication tokens. And it's something that a lot of the community is very happy with. So just as an example of what some code might look like, you might have a client that will make its own Keystone client session, Keystone auth session if another session isn't passed into it. And so what that might look like is something like, well, if we have a session, just return the session right away. Otherwise, figure out what the plugin is that we're trying to load. In this case, I'm just always using token. Pass it some options, and those options might be the username, the password, the tenant, or project name, the user domain name, the project domain name, a whole bunch of different attributes. The auth URI or the auth URL. And so what that gives us is a auth plugin that we can then pass into the Keystone auth session. And then we can also say whether or not to verify the certificate that we're talking to Keystone over. So this would just be some code that would get us a valid session to use when talking to Keystone and pretty much any other service, because a Keystone auth session is not just useful for getting a token from Keystone auth or from Keystone. It's also very useful for talking to whatever service we want to talk to. It provides a nice uniform interface, and it's flexible and very, very simple, right? It gives us the benefit of standardization because if every project uses the same session object, then any fixes that we need to introduce can be introduced in one place in Keystone Auth. For example, the OpenStack infra team integrates with a lot of different public clouds. And what it would find when talking to some public clouds was that it needed to set some TCP options on the socket itself. Requests kind of supports that. And so in Keystone Auth, there's actually a TCP keep alive adapter that you can use if you know you need it. I'm pretty sure it's mounted by default for Keystone Auth, which means that any client that talks to a cloud service that might need this will have it on by default, which will save you from having a socket connection that causes your program to hang for 2.5 hours or whatever the default socket timeout might be for your system. So moving on, finally we get to Betamax. You're probably wondering, okay, so I know about Keystone, I know about testing. What does Betamax have to do with any of this? Well, Betamax is a library that is primarily used when you're writing tests for something that uses requests. Betamax is specifically written for requests because I only ever use requests since I maintain it. And I need a library to help me test the code that I write that uses requests. Betamax will spy on your session's activity and record both the requests and responses, which we call a request response pair is something we call an interaction. It will record that into a file. A single file, which we call a cassette, can have many interactions, so it can have many pairings of requests and responses. And we store that file on disk where you tell us to. It serializes as much as it can about the request and the response. And that way, when you rerun that test, instead of talking to the service, it will use what's on disk. So what may have been, like, let's say the first time you wrote a test, it took you 20 seconds because you had 10 HTTP calls in that test function. The next time, it might take you about 2 seconds or less, because all it does is it reads the file, and then every time it sees the matching request, it returns the response for that. So it'll speed up your tests, and it'll make things more realistic because you're using data that is fairly realistic data. So why Betamax is kind of a hard question. Right now, most of OpenStack uses requests mock and other mock-like objects, as I mentioned earlier, to test different things. A lot of times you'll see a mocked out dictionary that represents like the JSON data for a response or something else that is about 20 lines inside of a test or inside of a test file. And it's all handwritten. And whenever the API that is mocking out changes, there has to be a lot of changes to each of those handwritten pieces of data to make that test then represent the new reality of that new API. That's kind of a lot of busy work for a developer, right? Like we all want to be fixing bugs, not fixing tests. So what Betamax allows you to do is it allows you to stop having to mock out the data and write something that looks kind of real. It allows you to use real data. And then when that data changes, when you're aware that that data has changed, you simply remove the file, rerun the test, and it'll re-record the file with the new data for you. That means that literally all you have to do is remove a file and run the tests, as opposed to fixing the tests, running the tests, and then making sure that you fix the tests correctly. So Betamax may sound pretty great right now, or it may sound terrifying. Depends on your point of view. I've heard feedback from people with both reasoning, with both responses. So let's look at how you might use Betamax. We need a session from requests. Betamax does not work with the functional API from requests. And that's fine for OpenStack because OpenStack never uses the functional API. They always need the connection pooling benefits. You create a Betamax object, which we call the recorder. You pass in the session, and you pass in the directory where you want to store the cassettes. And then you can say, use the recorder object as a context manager, and you tell it what the name of the cassette should be. Since I'm talking to everyone in New York City, I just called it NYC. You can call it pretty much whatever you want. Personally, when I use Betamax, I always give it a file name that's related to the test that I'm writing. So inside of the context manager, we use our session to make a bunch of requests if we want to, and all of those will be saved. Here we only make one, which is a very similar usage to what I showed you before when we were using requests. But in this case, what you'll see in the cassette, if you were to introspect it, would be a GET request to httpbin.org/get, and then a response that has the exact same data that you would get the first time around. And it's that simple. The first time you run it, if the NYC cassette doesn't exist, it'll create it and save the data. If it does exist, it'll just reuse it. So you might have an idea where I'm going with this now. Because I talked about testing in OpenStack and test fixtures and Keystone Auth and Betamax. Morgan Feinberg, earlier this year, or maybe late last year, added the Betamax fixture to Keystone Auth. Their purpose for doing this is that they wanted to use this fixture inside of the OS client config library. That way, when they test against different public clouds that OpenStack Infra uses, they can record real data and test that as opposed to writing out mock data that might change. So far, they haven't gotten that far with it, but the Betamax fixture does exist in Keystone Auth. And I posit that the fixture is actually very useful for people working on other projects, not just OS client config. It's useful for people who want to switch, say, Glance client to use Keystone Auth, or people who want to write integration style tests with real data for Magnum client, or pretty much any of these clients that are you already using your Keystone Auth or are going to shortly switch to using Keystone Auth can start using the Betamax fixture that's included in Keystone Auth. And it will make testing some of these things a lot easier. That means that you don't have to write mock data for integration tests, which is something you should never be doing in the first place. So let's give you an example of how you might use it. I didn't want to try and do this with any specific client because I didn't want anyone to think, oh, I should go do this to that client. But if we have a fake client that kind of looks like the code I showed you earlier, where if you pass in the session, it already uses that session. Otherwise, it'll make a new one from Keystone Auth. We import the Betamax fixture from Keystone Auth library, and then we import test tools. we make our test client class for our XUnit style testing. We define our setup method for our test case class. And because I didn't want the text to be too small, I kind of shortened the variable names, but you can use much better ones if you ever actually do this. So we have some method that generates a cassette name from the current test name, which is usually what I do. We create the fixture, and then we say we want to use that fixture by just assigning it in the setup, because a test case class, as I said earlier, also has a use fixture method. And then we create our client, because the Betamax fixture will actually monkey patch part of the Keystone auth library, such that when you create a brand new session, it will actually instead be using a Betamax session. So it's a session that looks kind of like what a session would look like after it's passed to the Betamax object in the actual Betamax library, which I showed you earlier. So that's just the setup. But then for our actual test, we could say self.client.list with whatever parameters we want to pass to the list method. And then we can make assertions about the objects that would be very, very accurate, because whatever service we're testing against, whether it be a local DevStack installation or a real cloud or anything like that, we could make very valid assertions about what those objects look like and what the data is on those objects and everything else. We could say we are certain that the objects will only, if we have like some kind of limiting parameter, like we only want 25 of those objects in the first page, then we can just say, assert that there's only 25 objects here. And that way, you can make better assumptions both about the behavior of the client, that it's doing the correct thing, and also about the data that you get back from the service. The other great thing is that, as I showed you earlier, the fixtures library allows you to reuse other fixtures. So for example, if Glance Client adds Keystone Auth support, and then decides that it wants to allow other users who are relying on Glance Client to do the same thing, they can create their own test fixture and distribute it as part of the library that will reuse the Keystone Auth Betamax test fixture, which means that anyone who integrates with Glance Client and writes tests against that integration can then also use the Glance Client Betamax Keystone Auth fixture, whatever we would call it, right? That means that they can have better tests on their end, which is a definite win for anyone using Glance Client. And it means that there's less code that's being shared between libraries. There's no need for Glance Client to invent its own Betamax fixture, because it can just reuse what Keystone Auth has. And that just makes life better for everyone, right? Because, I mean, how many different services use Glance Client? Probably Nova. Absolutely Nova, actually. I think Cinder does it sometimes. Magnum uses it a lot. So, I mean, there's other services in OpenStack that benefit from this kind of code reuse and consideration for other projects. And beyond that, anyone who's using Glance Client to integrate with a cloud can write their own tests. So OpenStack Infra with OS Client config can say, well, I'm using Glance Client, let me use the Glance Client Betamax fixture. Talking to Glance, and it just works. It's very, very convenient the way Morgan set up Keystone Auth and the way Betamax works. I'm out of time. I already discussed the benefits, so I'd like to thank you for your attention. And if anyone has questions, I guess Nikhil will turn on the mic soon, and I'll be able to answer them.
Thank you, Ian. It was a great presentation. I learned a lot, and I may start with my own question.
Sure.
So, do you know some of the glance tests that we can start implementing this on right away?
I didn't look into that. I can probably look into that and figure it out. I think we should just write new tests, actually. Because then once we have the new tests in place and we can prove that they work against, for example, DevStack or something else, we can then go through and look at the Glance Client tests that have a lot of these dictionaries that are meant to mock out response data from the Glance server, and we can get rid of those. I mean, we might want them for certain special edge cases that we can't get the server to reproduce, because that might be something that was a fix for an older version of Glance that we still want to support. but we can judiciously remove the other mock tests that exist.
So please correct me if I'm wrong, but I'm thinking we have some of the glance tests that are either in the integrated or functional directory, and they pull down the data from remote server and then they perform some certain actions on that. So is that where we could start using this?
Right. And those functional test cases are actually beneficial in my opinion because, well, most people don't run the functional test cases. Those are usually run at the gate. So where this would save time would be where Glance itself integrates with another service and talks to that service through a client, or where Glance client is testing against Glance itself. And so Glance client can have those functional tests, which are great, but it can also have local integration tests that are also run based on the cassettes, and that could save people a lot of time from having to set up a dev stack to run the functional tests for Glance client, because it'll give them a reasonable assurance that something is correct.
Gotcha.
So functional tests are absolutely valuable. I totally don't know why I didn't mention them in my talk. But functional tests are very valuable and very good to have.
Tests and Glance which could benefit from removing some of the data that exists associated with them, like it pulls down the data from example.com and then it performs certain actions on them. I think those things.
Yeah, you could absolutely. I mean, that would also save you from having to talk to example.com every time you run those tests. But yeah, absolutely, that would be a great example of a test where you could use Betamax instead.
Cool. Any other questions?
That's it. So the very fact when he said Betamax can be used to, so we are here to fix bugs and not test, as in, and he uses JSON. Could you just explain a bit more?
Can you repeat the question?
So the very fact when he said that want to fix bugs and not test, and Betamax helps you do it with help of JSON, I was not clear with that part.
So the question is that I think there was a mention that Betamax uses JSON.
So we want to fix bugs and not test. That's what he said.
So we want to
Right.
fix bugs but not test.
Yes, that was the whole concept, and Betamax helps you to do it better. And how was that?
So can you be more explicit on that?
Sure. So Betamax stores the interactions in the file, like I said earlier. What that means is that anytime you want to replace that data for those interactions, you can just remove that file. And when you rerun the tests, Betamax and your tests will regenerate that file. It's simpler that way because you don't have to think about what the server is now returning versus what it used to return. And it means that instead of about 100 lines of updates to a test file or several test files, you're simply removing a couple cassette files and then regenerating them. That means that your test code itself doesn't change, but the fixture data that it relies on does change. And that means that once you've fixed your client code, that test is actually testing, your test should continue to pass. Your test shouldn't need to be fixed because your test should just always be correct. And whatever the client is doing to parse the data coming back from the server, that it will be replaying from the cassette files. You're fixing your client code, not your client code and the tests all in one. So a review for like a bug in Glance client that talks to something else, instead of looking like 2 lines in the Glance client actual code, and then maybe 100 or 200 lines in the test fixture data that's handwritten into the tests themselves, it would look like 2 lines in the Glance client code, and then a couple replaced files that really don't need to be reviewed at all because they're just generated data. So it also makes the job a little bit easier on reviewers.
Yeah, that makes sense.
Yeah.
Does that answer the question, or do you have any other questions to clarify?
Yes, it does.
Makes sense.
That was quite helpful.
Yeah, very good.
Some, a fresh perspective on testing, right?
Yeah,
How we can do it.
that's right.
Yeah, I guess that was it. Since you don't have a Q&A feature enabled on Hangouts on Air, I think the viewers who are online now may not be able to ask questions here. But I think you can let them follow up on IRC or Google Plus comments or Twitter for follow-up questions. And I think you may just get some more once people start looking into the YouTube stream once it gets published.
Great. And I'm always available on IRC. I'll put that slide back up, actually. And I'm always happy to answer questions on Twitter if people have them.
Excellent.
Thank you.
Thanks, Ian.
Thank you.